We are looking at supervised machine learning process under which we are in step 4, which is feature engineering. So the feature engineering can be done through feature selection, so where we have seen uh, univariate selection, z test, t test, chi-square test, ANOVA, and f test, NORF test. This is what we have seen there. Then we have moved on to the uh, algorithms, feature selection algorithms, which are filter type feature selection, variance threshold, information gain, wrapper type feature selection, recursive feature elimination, and the third one is embedded type feature selection, which are lasso, ridge, elastic net feature selection algorithms we have seen. Now it's time to move on to the feature extraction. In feature extraction, let's begin with dimensionality reduction methods. So first we will see what is dimensionality reduction method, then we will get into the various types of dimensionality reduction methods. We will do a practical demonstration of each with an example. So let's begin with dimensionality reduction, which is a part of feature extraction and which is the step for a feature engineering of supervised machine learning process. So what is a dimensionality reduction? So dimensionality reduction methods or techniques used to reduce the number of input features or variables in a dataset while retaining the most important and relevant information. So these methods are particularly useful when working with high dimensional data where the number of features is large compared to the number of samples. So now that's what is our dimensionality reduction methods mean. Now let's look into the history of dimensionality reduction. So the field of dimensionality reduction has a long history and has been studied in various domains. So let's look into some of the notable techniques and contributions include. First one is 1901, which is principal component analysis, PCA. So it was proposed by Carl Pearson in 1901. PCA is one of the earliest and most widely used dimensionality reduction methods. So it aims to find the orthogonal directions in the data with the highest variance, and that's what is our PCA. Then from 1900 to 1936, the journey as the journey is going is happening from 1900 to 1936. Then we moved on to the linear discriminant analysis, LDA. So 1936, linear discriminant analysis introduced by Fisher in 1936. LDA is a dimensionality reduction technique that aims to find a linear projection of the data that maximizes the separation between different classes, and that's what happened in 1936. Now let's move ahead from 1936 to 1950 and let's see what had happened. So in next is in 1950s, multi-dimensional scaling, MDS, developed by Torgerson in the 1950s. So MDS is a technique that aims to find a lower dimensional representation of data while preserving the pairwise distances between data points. That's what is multi-dimensional scaling. So multi-dimensional scaling is a technique that basically aims to find a lower dimensional representation of the data while preserving the pairwise distances between the data points. Now let's move ahead from 1950 to 1999 and let's see what had happened. So, non-negative matrix factorization, we call it as in short NMF, non-negative matrix factorization. So, proposed by Lee and Seong in 1999. NMF is a dimensionality reduction technique that decompose a non-negative matrix into two low-rank matrices, and this is what we call it as a non-negative matrix factorization. So this is the history of and significance of dimensionality reduction methods.